Okay, in this video, we're going to be picking up where we left off on Tuesday. I went over I started section 4.4, which is exponential and logarithmic equations. And we talked about two different methods of solving exponential equations, one by expressing each side as a power of the same base, and the other one was basically using logarithms. We did some examples of that. And then we talked about what a logarithmic equation was. And the only thing I went over was using a definition of a logarithm. All right, these are the examples that I went over. You should already have those in your notes. What I want to do is pick up with one example where you're going to have to do the check on all of your proposed solutions to find out which ones satisfy the original equation and which one does not satisfy the original equation. Okay? Now, and I left off with example number 5. So here it is. Example 5 reads, the log of x plus the log of the quantity x minus 3 equals to 1. Okay? Log of x plus the log of the quantity x minus 3 equals to 1. Now, in this case here, this is a little different because the first step you have to do there is write the equation in the form of log to the base b of m is equal to c, meaning you need to write that as a single logarithm. Here, we got the sum of two individual logarithms. And this is where we're going to have to use what they call the product rule. Sometimes you may have to use either the product rule or the quotient rule or the power rule. Here we got the sum of the individual logarithms, so we must apply the product rule. And write that as the log of x times x minus 3. And that will be equal to 1. So now we have a single logarithm. And in this case here, we can convert that logarithmic equation into its equivalent exponential form. Now here we don't have a subscript for the log. However, it is understood to be a base 10. That's one of our common logarithms. Anytime you don't see a base for your logarithm, it's understood to be base 10. Now we can write it in exponential form. So in this case, I'm going to write that as, this is my base, which is your 10. The 1 will be the exponent for the 10. That's going to be equal to that expression right there, x times x minus 3. So here I'm going to have 10 to the first equal to x times x minus 3. And now I'm going to simplify that particular equation. Well, 10 to the first power is 10. And then x times the quantity x minus 3, if I use the distributive property, that would be x times x, which is x squared, minus x times the 3, that would be 3x. So now I have a quadratic equation because of that x squared. And when I have a quadratic equation, I need to get a 0 on one side of this equation. What I'm going to do here is move the 10 over to where the x squared minus 3x is. I'm going to do that by subtracting 10 on both sides. So now you got x squared minus 3x minus 10 equal to 0. And in this case here, I'm going to factor that x squared minus 3x minus 10. And in this case, that x squared, I can break that up as x times x. Now, I need factors of negative 10 that would give me a negative 3x as a middle term. Well, I know 5 and 2 would work. Now, the larger of the two factors takes the sign of a middle term. The middle term is a minus, so that 5 has to be minus, and the 2 has to be plus. So I get x minus 5 times x plus 2 equal to 0. And then we're going to set each binomial factor to be equal to 0. So this means x minus 5 equals 0, or x plus 2 is equal to 0. And then we're going to solve that particular equation for x. We'll solve each equation for x. So for the x minus 5 equals 0, if I add 5, you're going to get x is equal to 5. Or for the x plus 2 is equal to 0, if you subtract 2, you'll get x equal negative 2. So x equal negative 5 or x equal negative 2 would be my proposed solution for that logarithmic equation. But, of course, you have to check your proposed solution. You want to find out which of these x values will satisfy that original equation. So here is that all-important check, starting with x equal 5. Using the original equation that you see here, I'm going to replace the x with 5. So it'll be log of 5 plus the log of 5 minus 3 equals 1. And then, if I do 5 minus 3, I'm going to get 2, so I have log of 5 plus the log of 2 equaling to 1. Now, I have the sum of the individual logarithms. I can condense that as the log of the product. So here we're going to have the log of 5 times 2 equaling to 1. And if I multiply 5 times 2, I'm going to get 10. So the log of 10 should equal to 1. And if you had a calculator, press the log key, type in the number 10, you'll get the answer of 1. And that checks. So we can say x equal 5 is a solution to that logarithmic equation. Now for the x equal negative 2. Watch what happens when I replace the x with negative 2 in the original equation. I'm going to have problems here because already I can't take the log of a negative number. I can't take the log of a negative 2. And if I do negative 2 minus 3, I'm going to get negative 5. I can't take the log of negative 5. Here, it's not going to be true for negative numbers here when I take the log of a negative number. So, I need to eliminate x equal negative 2. That's your extraneous solution there. So, this means that x equal 5 has to be the solution to that logarithmic equation. Okay. So that was the other example that I wanted to do here, where you have to condense as a single logarithm, convert it to exponential form. Here you're going to have to factor, because it's a quadratic, and then you have to eliminate, you have to do the check on each one of those. And if you get a false statement, then you have to eliminate that x value. Okay. All right, now, the second method that I left off was solving a logarithmic equation. And this is where you got the logarithm on both sides of the equation. The one I just did had a logarithm only on one side. Well, let's say the logarithm is on both sides of the equation. So that second method would be to use the one-to-one property. And here's the procedure for that. The first step is to express each side of the equation in the form of log to the base b of m equaling to log to the base b of n. Okay? On both sides or on one side of the equation, you may have to condense using either the product rule or the quotient rule or the power rule before to start this off. And then number two, you're going to use that one-to-one property. And the one-to-one property states if log to the base b of m equals log to the base b of n, then m equals n. So if you have the log of the same base on both sides of the equation, then you can set this argument m equal to that argument n. So you can set m equal to n. And then number three, solve for the variable. And then number four is to check your proposed solutions. And again, you have to check your proposed solutions. You want to find out what values of x where you're not going to get a log of a negative number or the log of 0. And the same holds true for natural log of 0 or the natural log of a negative number. Okay. So now let's look at a couple of examples of just that. Let's say we have this. The log of x plus 11 is equal to the log of x plus the log of 11. And these are problems that are similar to the ones that are in your homework. Okay? So in this case here, if you look at the left-hand side of this equation, you'll see that we have a single logarithm of log of x plus 11. But notice on the right side, we got the sum of their individual logarithms. We need to condense that as the log of the product. Here we have to use the product rule because we got a plus sign in between our logarithms. So we need to condense that as the log of, I'm going to put the 11 in front of the x, because that's x times 11, but it's really 11x. So now I have a single logarithm on the right side and on the left side. Now this is where I can use the one-to-one property, where if I have the log of this understood base 10 and the log of the understood base 10 here, they're both the same on both sides. I can set this expression of x plus 11 to be equal to that expression, 11x. Okay? Because I got log to the base 10 on both sides of the equation. That's the one-to-one property. Set this expression equal to that expression. That's what I have right here. Now I'm going to solve for the variable. Well, let's get the x on one side. I'm going to move that x over to where the 11x is by subtracting x on both sides. So now I'm going to have 11 is equal to 10x, or 10x equal to 11. And then I'm going to divide both sides by 10 to get x by itself. So now you got x is equal to 11 over 10, but I'm going to convert that to a decimal by doing, of course, 11 divided by 10, which is 1.1. So I'm going to let x equal to 1.1. And I'm going to use that to help me do the check of that proposed solution. Using the original equation, I'm going to replace the x with 1.1. Okay. on the left side, if I add 1.1 and 11 together using your calculator, that'd be 12.1. Equal to, now on the right side, I got the sum of the individual logarithms. I'm going to write that as the log of the product. So this will be the log of 1.1 times 11. And if I multiply 1.1 times 11, I'm going to get 12.1. So if you multiply 1.1 times 11 on your calculator, you'll get 12.1. These two are exactly the same. So that checks. So I can conclude that x equal, I'm sure they want this as a fraction, as 11 over 10. If you were to do that in MyLabs Plus. So x equal to 11 over 10, or 1.1, is going to be the answer. But more than likely, they want this as a fraction, 11 over 10. Okay. All right, next we'll look at this one. The log of x plus 10 minus the log of 2 is equal to the log of 4x plus 1. The log of x plus 10 minus the log of 2 is equal to the log of 4x plus 1. Okay, now, on the left side, notice I got the difference of their logarithms. The difference of their logarithms, I need to condense that as the log of the quotient. That one I had to use the quotient rule here. So I need to write that as the log of, that x plus 10 will be in the numerator, and the 2 has to be in the denominator. If you recall, if you have a plus sign, or instead plus sign in front of the logarithm, when you're condensing it, it goes in the numerator, and the minus sign in front of the log means the number after that goes in the denominator. So we've got the log of x plus 10 divided by 2 equal to, the right side is a single logarithm, log of 4x plus 1. Now again, I'm going to use the one-to-one property. Here I got the log of the understood base 10 on both sides. They're both the same, so I can set that x plus 10 over 2 to be equal to the 4x plus 1 on the right side. And now to solve for x, well, I got that 2 in the denominator. I'm going to get rid of that by multiplying both sides by 2. This will be 2 times that 4x plus 1. And in this case here, those 2's divide out on the left-hand side. I'm going to be left with x plus 10 equal to, and if I distribute that 2 over the 4x plus 1 by multiplying, 2 times 4x will be 8x, plus 2 times 1 will be 2. So I get x plus 10 is equal to 8x plus 2. And now we're going to solve for x. Well, let's move this x over to where the 8x is by subtracting x on both sides. So now you're going to have 10 is equal to 8x minus x, that will be 7x plus 2. And now to get that 7x by itself, I need to subtract 2 on both sides. So that means 8 is equal to 7x. Divide both sides by 7, you'll get x is equal to 8 over 7. Now, we're not done with that problem because we have to do the check on this as well. Here's the check. Using the original equation that I started off with, I'm going to replace each x with 8 over 7. So I got the log of 8/7 plus 10 minus the log of 2 is equal to the log of 4 times 8/7 plus 1. Now I'm going to show you how to enter 8/7 plus 10 in the calculator and get the fraction for it. Okay, in this case here, I'm going to do 8 divided by 7, and then plus 10. Then I'm going to hit the math key right up here on the left-hand side, press that math key, convert that, as you can see, number 1 is a fraction, so I'm going to select number 1 for a fraction, and then hit enter. And that will give me the log of 78/7. And then minus the log of 2 is equal to the log of, now that 4 times 8/7 plus 1, I'm going to show you how to enter that as well. 4 times 8 divided by 7 plus 1. Then hit your math key, then select number 1 for fraction, and then hit enter. That will be 39/7 on this side. Now, on the left side, if I have the difference of the individual logarithms, I can condense that as the log of the quotient. So this will be the log of, this will be 78 divided over 7, all divided by 2. That should equal to the log of 39/7. Now, this right here, if I do 78 divided by 7, and then divided by 2, hit your math key, select number 1 for fraction, guess what? You're going to get 39/7 for all of that. So the log of 39/7 is equal to the log of 39/7. That checks. So in this case, x equal 8/7 will be the solution to that logarithmic equation. Okay. Now, of course, if you have any questions about this, you can email me or come by my office and see me and ask questions as well. Okay, out of this though, one more thing I need to cover is the compound interest formulas. We're going to revisit those that we talked about way back in section 4.1. There were 2 formulas that I gave you. For n number of compounders, whether it's compounded semi-annually, or compounded quarterly, or compounded monthly, or compounded daily, you have to use this formula. A is equal to P times the quantity 1 plus R divided by N raised to the N times T power. That's what you have to use here. Now for continuous compounding, required you to use this formula. A is equal to P times e to the RT. Those were the 2 formulas you had to use here. Now, because in those formulas we were only finding the amount. This time, we can either find out the amount of time it takes for an investment to reach a certain amount at a given interest rate at a given compounding. Or we can find out what the interest rate is. Okay? But for the sake of time in this course, we're only going to be finding out the amount of time it takes for one investment to reach a certain dollar amount. Like in this example. Let's say you had a $1,000 investment $1,000 investment. And you want it to grow to $3,600, and the interest rate is at 8% compounded quarterly. How long will it take for that to happen? So I want to know, how long will it take for a $1,000 investment to get to $3,600 at 8% compounded quarterly? All right, let's take a look at what we already got. We have a $1,000 investment, so your P is going to be $1,000. And we want the amount to be $3,600, that's your A. And the interest rate is 8%. Now, 8% as a decimal, if you don't know, you can do 8 divided by 100, that will give you the decimal form of that interest rate, 0.08. And it's compounded quarterly. That means there are 4 compoundings in a single year. So your N is going to be equal to 4. Okay, now for N number of compoundings here, we must use that formula. A is equal to P times 1 plus R divided by N, and that will be to the N times T power. And now we're going to substitute those values into that particular formula. So A is 3,600, and that's going to be equal to your P, that would be 1,000, multiplied by 1 plus R. In this case, your R is going to be 0.08, divided by N, which is 4, times N, again, that's going to be 4, but T is what we're trying to find. So your exponent there will be 4 times T. That's what we'll use here. Now I'm going to simplify what's in the parentheses here. If I have 1 plus 0.08 divided by 4, that would give me 1.02. So this will be 3,600 is equal to 1,000 times 1.02 raised to the 4 times T power. Now here I have an exponential equation, as you can see. So now I need to get that exponential part of 1.0 raised to the 4t by itself. It's being multiplied by 1,000. So I need to divide both sides by 1,000. And when I do that, 3,600 divided by 1,000 would be 3.6. That's equal to 1.02 to the 4t power. So now that exponential part is by itself. And when we solve an exponential equation, if you recall on Tuesday's class, you have to take the natural logarithm on both sides. So here I need to take the ln on both sides. I have ln of 3.6 equal to ln of 1.02 raised to the 4 times t. And now on the right side, I have to use that power rule by bringing the 4t, which is my exponent, in front of the natural logarithm. So I'm going to have 4t times ln of 1.02. And now I can get the t by itself. It's being multiplied by the 4 and the ln of 1.02. So I'm going to divide both sides by 4 ln of 1.02. That means I'm going to have t by itself. And this right here I'm going to enter into the calculator. Okay? So I'm going to have ln 3.6 That's going to be divided by, now that denominator, I need to put that in parentheses here. So this will be left parentheses 4, and then press the ln key, 1.02, close the parentheses for the ln, and then I'm going to close it again because I opened it when I started off with my denominator. And then press enter. Now let's say I want to round that off to 1 decimal place. So in this case here, 16.171266135 to 1 decimal place would be 16.2. So it's going to take 16.2 years for a $1,000 investment to reach $3,600 at 8% compounded quarterly. Okay. Okay, now I'm going to do one more example of a compound interest formula. I'm going to do the one with the continuous compounding formula in it. Okay. Let's say I have an $8,000 investment. And I want to double that amount at 8% compounded continuously. How long will it take for that to happen? So I want to know how long will it take for an $8,000 investment to double at 8% compounded continuously. All right, so here's what we have. We have an $8,000 investment, that's your principal, your P. We want to double it. If we got $8,000 and we want to double it, that amount has to be 2 times 8,000 or $16,000. That's the amount, because $16,000 is double $8,000 at 8%. 8% as a decimal will be 0.08. And it's compounded continuously. So we need to use this formula. A is equal to P times e to the RT. A is equal to P times e to the RT. Now let's substitute those values into that equation. Here we got 16,000, that's going to be your A, equal to P, that's 8,000, times e to the R, that's your 0.08. T is what we're trying to find. So there's our exponential equation that we have here. Okay? Now I need to get that exponential expression by itself, e to the 0.08t. I need to get that by itself. I'm multiplying by 8,000, so I need to divide both sides by 8,000. So this will be e equaling to 0.08t, equaling to 16,000 divided by 8 will be 2. Okay? I also know that e and the natural logarithm are inverses of each other. So I need to take the natural log on both sides of this equation. Okay? So on the left side, I'm going to have ln of 2. But on the right side, if I have ln of e to whatever my exponent is, it would be whatever this exponent is. So ln of e to the 0.08t would be 0.08t. And then to solve for t, I'm multiplying by 0.08. I need to divide both sides by 0.08. So to find out what t is, here we got ln of 2. We're going to type in the ln and then the number 2. You want to make sure you close that parentheses around the 2. because you only want the natural log of 2. And that value will be divided by 0.08. And then hit enter. And let's say I want to round this off to the nearest tenth or to one decimal place. It will be approximately 8.7. And this will be in years. So it's going to take approximately 8.7 years for a $8,000 investment to double the $16,000 at 8% compounded continuously. Okay? Okay, so this pretty much wraps up section 4.4, Exponential and Logarithmic Equations. And that homework for that section will be available for you to complete and finish as homework. Okay, now the next thing I want to start is this handout right here. Everyone should have a copy of this handout. And this is going to be dealing with matrix solutions to linear systems. And the only thing we're going to do here is write the augmented matrix for the linear system and use matrices. And we're going to be using the calculator, which will help us do the Gaussian elimination to solve systems of linear equations. Okay, so this is section 6.1. It should be a handout. You should already have that. Okay, now a matrix or matrices, if we want the plural form of that, it is a rectangular array of numbers arranged in rows and columns. The numbers inside the brackets are called elements. So this is an example of what a matrix looks like. Here we got, in this case, 2 rows and 6 columns. So we can call this a 2 by 6 matrix. Okay? And in some cases, they use a capital letter to indicate a matrix. So here we can call this matrix A. And we can call it any capital letter that we want to. So that's what a matrix is and what it looks like. Okay, now an augmented matrix. What an augmented matrix is, it has a vertical bar separating the columns of the matrix into 2 groups. The coefficients of each variable are placed to the left of the vertical line, and the constants are placed to the right. And if there's any variable that's missing, then we have a 0 coefficient for that missing variable. Okay, here's a couple of examples here. On the left are systems of linear equations. Usually, in this case, it's going to be 3 variables, x, y, and z. Like for this one, 3x plus y plus 2z is equal to 31. X plus y plus 2z equals 19. X plus 3y plus 2z is equal to 25. We can write that as an augmented matrix. So here, that first column represents all the coefficients of x. The second column represents the coefficients of y. The third column is the coefficient of z. The last column are the numbers after the vertical bar. That represents the constant terms. So in this case here, that 3x plus y plus 2z equals 31, that represents this first row right here. The coefficient of x is 3. For the y, its coefficient is 1. For the 2z, that coefficient is 2. The 31 is your constant term. And then on the second row, the coefficient of x is 1. The coefficient of y is also 1. The coefficient of z is 2. And then your constant term is 19. And then on the last equation, x plus 3y plus 2z is equal to 25. That coefficient of your x term is a 1. And then for the y, that coefficient is 3. For the z is 2. And the constant term is 25. Now for this next one, x plus 2y minus 5z equal negative 19. Then y plus 3z is equal to 9. And z is equal to 4. In this case here, That first equation, your coefficient of x is 1, the coefficient of y is 2, the coefficient of z is negative 5, the constant term is negative 19. Now on the second equation, y plus 3z is equal to 9, there is no x term. So we need a coefficient there, which is going to be 0. For the y, that coefficient is 1. For z, that coefficient is 3. And for the constant term, it's going to be 9. And the last equation, z is equal to 4. Notice there is no x and y term here. So we need a 0 coefficient for that x and a 0 coefficient for the y. But for z, that coefficient will be 1. The 4 is your constant term. Okay? So that's how we write an augmented matrix from a system of linear equations. Okay? Now to get you started, we're going to determine if this order triple, in this example, 10, negative 7, and 11 is a solution to that system of linear equations. Here we got x plus y plus z equal 14, x minus 2y minus z equal 13, 2x minus y minus 2z is equal to 5. All right, we're going to start with the x plus y plus z equal to 14. Now here, this is an order triple, x, y, and z. I'm going to write this off to the side. Which means your x is going to be 10, your y is negative 7, z is 11. So here, your x is going to be 10. You're just going to substitute those values into that equation, where the left side has to equal to the right side. So x is 10, y plus y is negative 7, and plus z is 11. That sum should equal to 14. Now if I add 10 and negative 7 together, you're going to get 3. And add 3 plus 11, you'll get 14. So we know it's true for only the first equation. But we also got to check the second and the third equations as well. So in this case here, let's start with that second equation, x minus 2y minus z is equal to 13. Substitute the x with the 10, so you get 10 minus 2 times y is negative 7 minus z is 11. That should equal to 13. Okay, if I bring down the 10, minus 2 times the negative 7 will be a plus 14. Minus 11 should equal to 13. Add 10 plus 14, you'll get 24. 24 minus 11 will give us 13. And 13 does equal to 13, so we know it's true for the second equation. But what about the third equation? That order triple has to be true for every single equation. Now 2y minus 2z is equal to 5. So here we're going to replace the x with 10, so it'll be 2 times 10 minus y, negative 7, minus 2 times z, which is 11. That should equal to 5. Well, 2 times 10 will be 20, minus a negative 7 will be plus 7, minus 2 times 11, 22. That should add up to 5. Well, if I add 20 and 7 together, you'll get 27. 27 minus 22 does equal to 5. So as you can see, that order triple is true for all 3 equations. So we can conclude that the order triple 10, negative 7, and 11 is a solution to the system. Okay. So there's one problem on the homework where you have to determine whether that order triple is a solution to that system of equations here. That's how you would do that problem. Okay, now, in example 2, we're going to write the augmented matrix for the system of linear equations here. In part A, you got 9x plus y plus z is equal to 4. 3x minus 8y minus z is equal to negative 7. and x minus 2y minus 2z is equal to negative 5. Okay, so here's the augmented matrix. The vertical bar represents the equal sign, by the way. And if you want to, you can do this. Put x, y, and z, and c represent the constant term up top. Because the first column are the coefficients of x, the second column is the coefficient of y, the third column is the coefficient of z. The constant term goes after the vertical bar. And you want to make sure that x, y, and z are in order for all of your equations. Like 9x plus y plus 7z is equal to 4. Here the coefficient of your x is going to be the 9, so we write down the 9. For the y, its coefficient is an understood 1. For z, that coefficient is 7. And then the constant term will be 4. And now for the second equation, 3x minus 8y minus z equal negative 7. The coefficient of x is 3. The coefficient of y, negative 8. And the coefficient of z is an understood 1, but it has a minus sign, so it'll be negative 1. And then your constant, negative 7. And then the final equation, x minus 2y minus 2z equal negative 5. For the x, that coefficient is 1. For the y, negative 2. Z, negative 2. Your constant term, negative 5. So this is the augmented matrix that represents the system of linear equations. Okay, now for part B, we got x minus y plus 8z equal 5, y minus 12z equal negative 11, and z equal to 4. Okay, that's the setup for that. Now you can put x and then y and then z and then constant term c to help you out. For the first equation, x minus y plus 8z equal to 5. Well, that x has a coefficient of 1. The y has a coefficient of negative 1. The z has a coefficient of 8. That constant term is your 5. Now for the second equation, y minus 12z equal negative 11. In this case, there is no x term in that equation. So we need to put a 0 here in that first column, which represents your coefficient of x. And then the coefficient of y, that's an understood 1. For z, that coefficient is negative 12. The constant term, negative 11. The final equation, z is equal to 4. Well, in this case here, there are no x and y terms here. For the x coefficient has to be a 0. The y coefficient has to be 0. The coefficient of z is an understood 1. The constant term is 4. Okay. That's how we write an augmented matrix for any system of linear equations. Okay. All right, next we got this. We want to write the system of linear equations by, well, represented by that augmented matrix, which is this. 4, 0, 3, negative 17, 0, 1, negative 6, 14, 9, 7, 0, and 2. All right, I'm going to put x, y, and z and the constant term up at the top. And of course, here to write that system of equations, we have the augmented matrix here. We look across here. The first row is the first equation. This 4 represents the coefficient of x. That would be 4x. The 0 is the coefficient of y. It's 0y, but here, if we got a 0 for an x or y or z coefficient, we don't necessarily need to write that down. For the 3, that's your coefficient of z, and it's going to be a plus 3z. The vertical bar is your equal to symbol. The constant for that would be negative 17. Now for the next row, 0, 0, 1, negative 6, 14. That 0 is your coefficient of x, so I'm not going to write 0x. That's not necessary. This 1 is the coefficient of y, so it'll be 1y or just y. The negative 6 is the coefficient of z, so it'll be negative 6z equal to, the constant would be 14. And that's a z, by the way. Okay, now that last equation, 9702, but 9 is the coefficient of x, so that'll be 9x. But 7 is the coefficient of y, so it'll be plus 7y. 0 is the coefficient of z, so we don't necessarily need to write 0z. Then that's going to be equal to the constant, which is 2. So this is the system of linear equations represented by that augmented matrix. 4x plus 3z equal negative 17, y minus 6z equal 14, and 9x plus 7y equal to 2. Okay, now, the last page is solving a system of linear equations using your graphing calculator. And we're going to use the TI-83 or the 84 plus calculator. Here, most graphing utilities can be used to convert a matrix to what they call reduced row echelon form, or row reduced echelon form. Here, row reduced echelon form means that you must get ones along the main diagonal right here. This is your main diagonal. And you need to get zeros above and below each one of those ones here. And once it's in that row reduced echelon form, the numbers in the last column represent the values of x, y, and z. This is a quicker way of getting your values of x, y, and z than if you were to use the Gaussian elimination by hand. Okay? And I have a video that I've created that goes through that long method. Now, this right here is the graphing calculator procedure on your handout that shows you how to get the x, y, and z values using reduced row echelon form, okay? Rather than me go through all of that, I use this as an example here. Use matrices to solve this system, which is 2x plus y plus 2z equal 18, x minus y plus 2z equal 9, and x plus 2y minus z equals 6. First of all, I need to write that in as an augmented matrix here. So here's what I'm going to do. Create the matrix with a vertical bar for the equal sign, and this is going to be x column, y column, z column, and the constant. For the first equation, 2x plus y plus 2z equal 18. We write the numerical coefficients. For the x, it's going to be 2. For the y, it's going to be 1. For the z, it's going to be 2. The constant term is 18. And then, for the second equation, x minus y plus 2z equal to 9, that x has the coefficient of 1. This y has a coefficient of negative 1. The coefficient of z is 2, and your constant term is going to be 9. Then the last equation, x plus 2y minus z equals 6. That x has the coefficient of 1, the y has the coefficient of 2, the z has the coefficient of negative 1, the constant term is 6. Okay, now I'm going to enter this in my graphing calculator. Okay, I'm going to follow this procedure that you see at the top of example 4. Okay, I'm going to clear this screen out. First step is to access the matrix menu by pressing second and x to the negative 1. Here's the second key, which is that blue key or the yellow key, and then x to the negative 1 has matrix at the top. So you're going to press the matrix key. Second, x to the negative 1 for the matrix. You should see this menu right here. Now notice we're going to be putting in a brand new matrix here. So under number 2, you want to move the cursor to the right twice to get to the edit mode. That's what I did here. Use that right cursor, moved it, pressed it twice to get to the edit, the highlight edit. And I'm going to store this in matrix A, okay? So I'm going to select number 1 for matrix A. Now, the next step would be to type in the dimensions of this matrix A right here. This matrix right here. Here, I need to find out how many rows and how many columns I have here. Okay, notice I got 3 rows and 1, 2, 3, 4 columns. So this is actually a 3 by 4 matrix here. The first number is the number of rows. The second number here is the number of columns. So that in that first number where the cursor is blinking, I'm going to type in the number 3. Because I have 3 rows, and then I'm going to press enter. And then number 4. Type in number 4, because I want 4 columns. It's not going to show up all 4 columns on the screen here. Those dots here on the end represent there's more to it on the end, because the screen can only fit so much. Now, you're going to type in each number row by row, pressing enter after each number or after each element. So starting with that first row of 2, 1, and 18, you're going to type in the number 2 and then enter. It's going to go across, and then you have to type in the number 1 and then enter, and then 2, then enter, and then 18, and then enter. It's going to take you to the next row where you'll enter the next row numbers here, in this case. So here you're going to have to type in 1, enter, negative 1, enter, 2, enter, 9, and enter. And then it'll take you to the third row where you have to type in that third row numbers here. You'll type in the number 1, enter, 2, enter, negative 1, enter, and 6, enter. Now notice you have to type in that very last number for the last row and the last column, okay? Very important. Once you're done with that, the next step is to press second and mode to get out of the matrix menu. Hit the second key and then mode right next to it, because you want to quit and go to a clear screen. Now, we want to get RREF, which is reduced row echelon form. You're going to do that by pressing second and x to the negative 1. You're going to move that cursor over to the right one time to highlight the math menu. Now you're going to use your down arrow key to go down to the menu item that says RREF. That stands for reduced row echelon form, RREF. That's the one you want. Not REF, RREF. Highlight that, you'll press enter. Now we want to pull up that matrix that we stored, in this case, matrix A. So here I'm going to go to second, x to the negative 1 again. And under the names menu, I'm going to select number 1, because that's where I stored that matrix that I entered it into A. I'm going to select number 1. And if you want to, you can close the parentheses, and then finally press enter. That will be the matrix in what we call reduced row echelon form. Notice there are 1s along the main diagonal. You got 0s above and below the 1s here. Now, the numbers in the final column, those represent the values of x, y, and z. Because that's the ordered triple for this system of linear equations here. So I'm going to copy down what I have on the screen, which is in this case 1, 0, 0, and then 5, then 0, 1, 0, and then 2, 0, 0, 1, and then 3. Okay. Now, in this case here, the last numbers in that last column represent the values of x, y, and z, respectively. That first number is your x value, x equal 5. And then the second one is what y is equal to 2. And z is what this number is in that last number, 3. So the order triple that we were looking for is this: 5, 2, and 3. That's the order triple that satisfies that system of equations. Okay. Now here I'm going to end it right here. I think I have a homework for section 6.1, which I will open up for you to complete as homework, as well as the homework for section 4.4. Okay, now, do get some practice on this. Do email me if you have any questions or any concerns about using the graphing calculator. This should help you. You can watch this video as much as you want to on your own time. Okay, and I will be back in class on Tuesday. I do want to remind you about one thing before I sign off. Your next exam number 4, will be on the 18th, which is next Thursday. And I will have that review sheet posted on Canvas by Friday. So make sure that you print that off and bring it to class with you. I will remind this to you when I send the email out to you on Friday on Canvas. Thank you very much.